Alright, today we're going to be talking about properties of tangents. This is section 10.1. The first part of this notes is going to be all vocabulary for the most part. I'm going to start off by telling you the proper definition of a circle, which is a set of all points in a plane that are equidistant from the center. Okay, and now I'm going to define center for you. Center is in the middle of the circle, and it is equidistant from every point on the circle. So when I mean every point, so if this is the center, any point on the circle, it's going to be the same distance from the center. Alright, the next vocab that I'm going to teach you is called a chord. A chord is a line segment that has, sorry, my mind just went blank. It is a line segment that lands on the circumference of a circle. So it's not going to go through the circle. It's just going to connect one part of the circumference to another part of the circumference. So its endpoints lie on the perimeter of the circle. So a segment whose endpoints lie on the circle. So if these are the endpoints, they lie on the circle. Excuse me. The next line here is known as our radius. And the radius has endpoints. The endpoint is the center of the circle, and then it can be any point on the circle. Endpoint. Endpoints consist of the center and any point on the circle. Our next vocab word is going to be diameter. And again, radius and diameter should be a review for you. It should not be a vocab words that you're having troubles with. But basically, a diameter is a chord, which is one of our new things that you're being introduced to. So the diameter is a chord in which it contains the center of the circle. Okay, so the last vocab word that I'm going to, well, I've already said it. It's going to be the center, but I'm just going to go ahead and denote that for you. This is probably one I should have started off with, as the dot as center. And the key thing that I want you to take away from the center is The center of the circle is how we name the circle. So the center is how we name a circle. So whenever you're doing your homework, you might be reading a word problem, and it's going to show you something like this. It's going to give you a little circle with a dot in it. Oh, I'm kind of moving a little crooked here. So it's going to give you a circle with a dot in it, and right after that, it's going to name it, let's say, Q. So it's saying circle with the center of Q. Let's call that here. So if we wanted to name this circle, we would label the center Q, and so that's what this means. So you will see this in your homework. So just understand that this is how you name a circle, and this is how it's going to be denoted in word problems. Okay. I'm going to move this up. Here we go. We have a few more vocab words that we're going to be digesting here. This here is what's known as a secant, this line right here. And it might look similar to a chord, but there is a difference. The difference is that a chord is a segment, whereas a secant is a line. It's going to keep on going. So a secant is a line that intersects the circle in two places. So here and there. All right, and our next line down here, this is known as a tangent line. This is a tangent line. Okay, let me take a moment here to name this circle Q. And let's name this point P and this point M. Okay, and I'll get back to that in a minute. So a tangent line is a line that only touches a circle in one spot. Ooh, I spelled circle wrong. Circle in one touches a circle at. Let me say at here.
You're in the building, please come to the front office. Colin Boyette, please come to the front office straight away.
So a tangent line touches a circle at one point. Okay. The point at which it touches the circle is known as, we're going to call this P. It's known as point of tangency. So a tangent line touches a circle at one point, and the point at which it touches is known as the point of tangency. What you need to know about a tangent line is that it's always perpendicular to the radius. So let me move this up a little bit. The radius is perpendicular to our tangent. And this is going to be important for the rest of our section. All right, I'm going to go to the next page. Move this out of the way here. Let me zoom out a bit. Okay. I'm going to introduce Theorem 10.1 to you. You're not going to have to know Theorem 0.1 by verbatim, but it is good to know it. And the theorem basically says in a plane, a line is tangent to a circle if and only if the line is perpendicular to the radius, and which is what I mentioned right here on this part of the notes. So basically what you need to take from it is that the tangent at the point at which it touches the circle, it's going to be perpendicular to the radius. Okay. So from this picture drawn here, MP is our tangent line. And then the name of our circle is Q. And it's saying MP is tangent to circle Q if and only if the radius is perpendicular to MP. Alright, I'm going to move on now to Theorem 10.2. And Theorem 10.2 states that tangent segments form a common external a little better. External point are congruent. So basically that's saying if you have this tangent line here, if you have tangent line HK and you have tangent line JH, at the point that they intersect outside of the circle, these tangent lines are going to be congruent right here. So this is congruent to this segment. So segment HJ is congruent to segment HK. So let me write that. So we have HK congruent to HJ. And this is something that you're going to need to be really familiar with whenever you start having to solve for line segments. Okay. This next part of the notes is finding the radius and diameter of a circle that's on a graph. We're not going to go too much into detail with this because you will see this a little later on in the chapter. But basically, the easiest way to do this is just to count the units to where you're equally going across and vertical. So if I was to start here and count across 1, 2, 3, 4, 5, 6, 7, 8, that means I would want to go this way 8 too. And let's see, 1, 2, 3, 4, 5, 6, 7, 8. So then we know that this line right here is our diameter, and this right here is also our diameter, but I'm just going to mark this half as our radius. right here. That way we can see it. So we have our radius is 4. And we have a diameter of 8. Because if you were to count across, you would get 8. And if you were to count from the center of the circle up, you would have 4. Now the coordinate for our center, you're going to go over 4, up 4. And so that's going to be our center. Okay, and now we're done with that. And we're going to move on to circles with common tangents. And basically, circles with common tangents basically means that they share the same tangent line. So if I was to draw a line right smack dab in the middle of these two circles, it's going to intersect these circles at one point. And obviously these circles are a little squished, they look almost elliptical, but they are a circle. Just trust it. So it touches it there, so that's one tangent line. That's common for this circle and this one. And then if I was to draw a line right here, that would be another one. And this is where it touches. And then we can do the same for down at the bottom. Okay. So this tangent line is common with this circle and this circle. Let's name these circle A and B. So circle A and B share 3 common tangent lines. Okay, let's move on to this group of circles right here. Let's name this one C and this one D. So C and D, oh, that's not very straight. The easiest way to do this is to get a ruler and line it up to where it touches each circle only once, because that is our definition of a tangent. And so when you're eyeballing it, it can be hard to draw that straight line. So this line here intersects or touches this circle C once, and it touches circle D once as well. So they share this tangent line. And then we can do the same going this direction. It touches D once, and it touches circle C once. Now, for C, doesn't have really anything to do with tangent lines. This is just one more definition that we're going to throw in there. And this is basically called a concentric circle. And basically what that means is you have a circle inside of another circle, but they share the same center. So the center is the same, but the radius is going to be different. So share same center, but differ in radius. And that last vocabulary word is going to conclude this section. Hope you have a great one. See you in class.